In our world today, we use a lot of data. So, statistics are more and more important. However, statistics can be tricky. There are simple things like averages, but also much more complex concepts one might study in university. Because of this, people might find it hard to know which parts of statistics they need for their work. That's why this video is designed to help readers use statistics in a helpful and effective way as a big picture that gives a clearer, detailed view of the topic. The first time you meet with statistics could be when you see numbers arranged in tables or something similar. These tables might have values, averages, usual differences, and other key measurements. The mean, m, is a typical average we often use. It's adding up all the numbers and dividing by how many numbers there are. The standard deviation, st, tells us how spread out the numbers are from the average. Descriptive statistics is when we use these numbers, like the average and the standard deviation, to describe or talk about data. When we're going to look at two groups of scores, we want to see if these scores have any connection. To do this, we'll use two things: covariance and correlation coefficients. Covariance is a number we get straight from the data. But correlation coefficient is a special number, which can be from -1 to 1. This makes it easy to compare different data sets. A correlation coefficient of 1 means there's a strong positive link. Students with high math scores also get high English scores. If it's 0, there's no connection. If it's -1, it means there's a negative link. When one score goes up, the other goes down. Graphs are very important because they help us understand statistical results easily. There are many kinds of graphs like histograms, pie charts, box plots, and line charts. From here on, we will not only focus on summarizing data but also explore statistical estimation using the data. Before we look at different statistical methods, let's understand a basic idea called statistical hypothesis testing. Imagine we have two groups and we want to know if they are different. To examine this, we start by saying there is no difference between the two groups. This is our starting point or null hypothesis. We then use statistics to show that this is probably not true, which means that there likely is a difference. When we test this hypothesis, we use a special value called the p-value. This tells us how likely it is that our null hypothesis is true. If the p-value is less than 1% or 5%, then we say the null hypothesis is probably not true, meaning there is a difference between the groups. But, we can make mistakes in this process. One mistake is to say there is a difference when there is not. This is called a type I or alpha error. The other mistake is to say there is no difference when there actually is. This is called a type 2 or beta error. We can't completely avoid these errors. We can use a special way of scoring called deviation values in tests. Deviation values make sure all scores can be compared in the same way. We do this by using something called a z-score. The z-score sets the average score to 0 and a common difference in scores to 1. This helps us see different scores on the same level. After we find out the z-scores, we often use something called a normal distribution. It's like a tool to see how the scores rank among all scores. Normal distribution looks like a bell curve. It shows how many people got a certain z-score. If we think about a group of 100 people, the normal distribution of z-scores looks like this. About 34 people will have a score between 0 and 1, 13 to 14 people between 1 and 2, 2 to 3 people between 2 and 3, and maybe one person will have a score higher than that. In simple words, we use a t-test when we want to look at the differences between two groups. But, if we have 3 or more groups, we use another test called ANOVA. ANOVA can tell us if all the groups are the same or not, but it doesn't tell us which specific groups are different from each other. So, if we want to know this, we need to use the Bonferroni correction or Tukey's test. Until now, we've been talking about specific tests called parametric tests. But there are also other tests for comparing groups that don't assume any specific data distribution, called non-parametric tests. These include the Mann-Whitney test, the Kruskal-Wallis test, and the Steele-Dwas test. They're like the non-parametric versions of the t-test, ANOVA, and Tukey test. Another common non-parametric test is the chi-square test. Regression analysis is a method that helps us find an equation to predict values in one set of data based on another set of data. Imagine we have two sets of values, one for x and one for y. We can use the equation y equals x plus b to estimate the values of y based on x. By performing calculations, we can determine the specific values of a and b. When a study collects a large amount of data and deals with a lot of variables, different methods called multivariate analysis can be used to obtain various results. Multiple regression analysis is an expansion of single regression analysis and uses more values to calculate estimates. Factor analysis is a method to discover several underlying factors from a large number of factors. Discriminant analysis is a technique used to determine which group an element belongs to. Cluster analysis is a method of grouping elements based on their distance from one another. Principal component analysis is a technique for identifying factors that contribute more to explaining the data. Other techniques involve quantification, which allows the statistical analysis methods discussed so far to be applied to both quantitative and qualitative data. Additionally, path analysis and structural equation modeling, SEM, are used for more complex models. Starting now, we will look at how math helps us understand statistics. Sometimes, math can seem hard. So, I will also explain some math symbols and ideas to make it easier. When we learn statistics and math formulas, we often begin with ways to count, like permutations and combinations. This is key because we find probability by dividing the outcomes we want by all possible outcomes. To find probabilities correctly, we need to be able to work out all the different ways things can happen. The symbol sigma simply means the sum of all elements, making it much easier to represent the sum of thousands or tens of thousands of elements than listing them one by one. You may also notice that the button for calculating the total in Excel is represented by sigma. Variance and standard deviation are ways to show how much data spreads out. They show how far each piece of data is from the average. Conditional probability tells us how likely something is to happen if something else has already happened. A picture called a Venn diagram can help us understand this rule. Understanding conditional probability is very important because it helps us understand another important rule in stats called Bayes' theorem. Even though you can't fully avoid errors in statistical testing, you can use this fact to measure the accuracy of the test and find out how many samples you need for the result you want. The accuracy of a result is called the power of the test. We can't eliminate all errors, so it's important to balance the test power with what's possible in the real world. The formulas for both parametric and non-parametric tests discussed earlier are given. It's important to remember that the symbol sigma in many of these formulas shows that they are made up of a series of smaller calculations. In single variable regression analysis, we find the slope and intercept by calculating the mean, variance, and covariance of two variables, rather than finding different constants with a method called least squares. For calculations involving more variables, you need to know calculus and matrices. These more complicated calculations are usually done later on.
If you want to learn more about math methods, you can read many books on this topic. For those who want a quick overview, let's talk about what math statistics usually includes. Let's talk about two important math tools, differentiation and integration. Differentiation is like looking really close at one point on a line. If you zoom in a lot, that point looks like a straight line. This makes it easier to understand complex lines by making them simple. For example, we know the Earth is round. But from where we stand, it looks flat. This is like differentiation. In graphs, differentiation helps find important points, like highest or lowest points. On the other hand, integration is like going from a tiny scale back to a big scale. In graphs, integration gives the space between the line and the bottom line. When we integrate a probability density function over a certain space, the result represents the probability of the random variable falling within that space. In mathematical statistics, it is necessary to calculate sigma and integration to find important values like expected values. Sigma is used to add up the total chance of a certain kind of probability distribution, and it equals 1. Integration is used for a different kind of probability distributions. Both expected value and variance can be found using sigma and integration. By using the idea of moments, we can label central values. Mean is the first moment, standard deviation is the second, skewness, tilt is the third, and kurtosis, sharpness, is the fourth. To find moments, we use different functions depending on the situation, like the moment generating function, probability generating function, and characteristic function. One symbolic example is the use of a technical method called Gaussian integration to show that the total probability of a normal distribution is 1. Central limit theorem says that when we have a lot of data, even if it comes from different sources, we can think of it like it comes from a normal distribution. Instead of just deciding to agree or disagree with a statistical testing based on the p-value, we can think about a range of possible numbers in the population. This range is called the confidence interval. After making statistical predictions, it's important to check how correct they are compared to the best possible guess, and to do so, we use methods called effective estimators to check this. There are many ways to work this out. Some of these methods involve using Fisher's information and the Kramer-Rao equation. We often change variables to make calculations easier when we're figuring out chances. For this, we use a method called substitution integral. We also use a thing called the Jacobian determinant to make this method even better. The normal distribution is one type we talked about in the testing section. But there are many other types too. Some examples are the uniform distribution, Bernoulli distribution, Poisson distribution, binomial distribution, t-distribution, f-distribution, beta distribution, gamma distribution, and Weibull distribution, among others. When we do math with lots of numbers and rules, it's good to have a way to work with groups of numbers, not just one by one. Like when we have many equations at once, we can show the rules and numbers with something called matrices. Matrices are good because they help us solve equations, move things around, and more. They also help us show chances of moving from one state to another, like in something called Markov chains. In regression analysis, we use a method known as least squares to make this difference as small as possible. This involves using math to find the smallest point of the difference. In multivariate analysis, we often use matrices to organize and work with the data. In statistics, math helps to show how good different models are. Techniques like the Akaike Information Criterion, AIC, and the Bayesian Information Criterion, BIC, use values we get during calculations. These help to find the best model from all the options. In something called Bayesian inference, we use methods like MAP, maximum a posteriori, and MCMC, Markov chain Monte Carlo. They use different kinds of probability distributions in math. Complicated distributions like the beta distribution and gamma distribution are used in real life. There are other ways to do statistical analysis. These include time series analysis, stochastic processes, and neural networks. If you need more information about these, please look for good sources. We changed the way we look at chance and statistics using a new way of thinking called measure theory. A measure is like a weight for each value in a total group. These weights help us ignore unusual data in real-world information. We call this idea almost everywhere. A well-known example of this is the Dirichlet function. When we use these measures for integral calculations, it's called Lubbock integration. The Lubbock integral is simpler to use when dealing with limits than the Riemann integral. It also makes changing the order of integration easier, thanks to Fubini's theorem. Measure theory can be useful for probability and statistics, which often deal with limits.
This video is a helpful guide for people who are not experts in statistics. It gives a big picture look at the topic and makes hard statistical ideas and words easier to understand. People can use this guide to learn how much they need to know about statistics or to better understand how certain ideas are used. This paper aims to help people do better in their research by helping them understand statistics better. Statistics is a big topic that uses a lot of math, and it can be hard for people who are not experts to understand it all. But if we look at statistics as a useful tool, we can use it to help us and make the field better. This is a good thing for everyone,